Hello, everyone, and welcome to today's SBA Live Academy. This time it's going to be about secure software development lifecycle and DevSecOps. Now, I first want to present myself very quickly. My name is Konrad. Most people call me Tom. I work for SBA Research in Vienna, and my topic is software security. I work for a software security team, and most of the time what I do is penetration testing, and security architecture reviews. I also deal with the secure software development process, assessments, and helping to improve the process towards more security. I'm also one of the founders of the Sec4Dev conference and bootcamp that we mentioned in the beginning. So software security and software development nowadays is a pretty tough topic because we're moving so fast. And moving fast in software development means that security has a hard time keeping pace. So if I do, say, for example, 3 or 4 or 10 or hundreds of software launches every day where I put code to production, there is no way I can do a penetration test before each launch. It's just impossible. Although penetration test is a good checkpoint for a certain stage of development, we need some way to keep pace with the speed of development and the speed of deployment. And that's really hard because we have to face it. There's no such thing anymore as a big bang launch. There's no such thing as I develop software for 10 years, and then once it's done, I'm going to launch it and it's going to stay there like that for another 10 years. That's not happening anymore nowadays, or very, very rarely. Now, as I said, security has a very hard time. It's kind of the last runner in the picture that you're seeing. It's always lagging behind a bit, and it's always trying to keep pace, and it's very difficult and tough. Now, before we start getting into how to approach this and how to improve the situation, I want to refer to this statement here on the screen: security costs money, right? I want to comment on this a little bit. Now, many of you might have seen this curve or this graphic here, where if you find a security vulnerability early in the development phase, say, for example, in the architecture and design phase, then it will be way less expensive to fix that vulnerability. Whereas if you have this mistake in the code and it's running in production and other pieces of software depend on this piece of code, then it's going to be very much harder. So it's an exponential curve. It's, way about flattening the curve, but in a different way today. So that exponential curve of the costs that you're going to face for fixing the problem is going upwards very, very quickly afterwards. Now, I work a lot with companies and software developers. I've been working with software developers since 10 years now, more than 10 years. And there's things that I see, or recurring patterns where I see that money is spent in the wrong way. So look at those bars here. So the height of the bar kind of tries to roughly indicate the severity of each of those vulnerabilities. So the higher the bar, the more severe the vulnerability. And I want to put some green bars above that kind of tell how much organizations and companies spend on fixing those vulnerabilities, and even if those two things are in line with each other. So you can see, or what I want to indicate, these are no numbers that are backed by research. It's just very, just to point across. Organizations are spending money for stuff that isn't really a big deal. They are spending the money in the wrong way or in the wrong places, whereas other problems are a big deal and there's little money spent on this. The third from the left, cross-site request forge, is a very classic example in web application development. It's a problem where people tend to build very complex solutions around that tend to fail, that tend to put other vulnerabilities in your code. But the solution could be very easy and elegant only if people understood in detail how the attack works, right? So I don't want to just spend more money on these things. What I want to do is I want to spend the money more effectively. I want to push the green and the red bars more or less in the same position. So spend more resources on stuff that actually matters and spend less resources on stuff that might be resolved in an easier way. So I don't want to just have more money as a security guy, or I don't want organizations to spend more money on security because I'm a security guy. No, I want to use that money and resources, or some time resources of developers, more efficiently. So that's what this all is about. You might have heard about the Gartner hype cycle approach. So I think that's a very good model to approach buzzwords and new things. You might have read DevSecOps and you might have told yourself, oh God, that's another talk about a buzzword and it's got a buzzword bingo. Not really. I want to really help in understanding what we can take out of this to really make use of this approach. Now, the hype cycle, what it tells us, there is a hype, there's a word, there is a technique popping up in the news. You can read it everywhere. Everybody says that's going to solve all our problems. So we're going up that hype cycle and to that top point where we have inflated expectations that we can never fulfill. And then people start trying things out, start to see not working so well as we expected. And then they push down to the throw of disillusionment where they see, okay, it's not really the perfect solution to everything. And then afterwards, we're going to pick out those things that are actually usable and useful in solving our problems. And this is where I want to get. You can see that down there, we're very in the lowest part with DevSecOps, so people realize it's not the solution to all problems. I want to go to that plateau of productivity with DevSecOps, and that's why we're diving right in. So solution approaches to the problem. So the first thing we need to consider, software security is not just about code, it's not just about penetration testing, which it is an important part, but it's not everything. We need to shift left in the software development lifecycle. Now, shifting left means the following thing. Organizations nowadays, or maybe a couple of years ago, where they typically were is at the very right circle. How can I recover? So there's a security incident, something bad happens. Somebody manages to attack our system or manages to launch a denial of service attack. How can I recover from the state? How can I get back to normal operations? And that would be the first step towards security. I have a problem and I try to fix this and get back to normal. Now, the next question I might ask myself if I want to get more mature in terms of my software development lifecycle is, how do I react appropriately the next time this happens? Or the next approach would be, how do I even identify the problems before somebody manages to exploit them? The next question, how do I protect against those things? And then you're soon gonna notice that you only have limited resources to implement security measures in your organization. And then finally, you have to ask a question, what do I have to protect and why? So what applications do I have? What data do they carry? Is it sensitive data? Or is it personal identifiable information or not? Depending on those things, I might have to put more time resources into the one application, the other is maybe not so important. So I want to get from this ad hoc approach to really integrating security in the lifecycle. So this would be security test before going live. How do I identify problems? And how do I react would be an incident happens and how can we get back to normal? Shifting left, where's left and right, you might ask. So in a software security lifecycle, there is not only coding, there are other things as well. So the typical software security lifecycle starts with requirements. I don't know who of you, if that were a real life thing, I would ask you to raise your hand if you have security requirements in your documents. Can't really do that now, but the requirements on the very left is something where you should start. So the next time you write functional requirements for your software, make sure to include software security requirements as well. Now, with all of the things, we're going through the hype cycle as well. First, we're not doing anything regards to software security requirements. Then I saw companies and customers of ours that put a whole application security verification standard, or ASVS, as a whole into the requirements document. That's 20 pages of security requirements. That's completely ridiculous. You're never going to be able to solve all the things. That would cost 100 times the budget that you have for a software. So we're kind of at the top of this application hype or the security hype cycle where everybody tries to stuff in there that doesn't even fit there. Then you see, oh, not going to work. I'm down there in the throw of disillusionment. Now, what I want you to get is pick out the stuff that is relevant and doable, right? So that's for requirements. Architecture and design, this is where, for example, threat modeling could happen. Those of you who have visited Sec4Dev, it was a threat modeling workshop. You might have, or you have learned how to do a threat model. That's where you do that. So design, architecture, technology decisions. Once you have all those diagrams and everything in place, this is where you do a threat model. Also test plans. So testing, have a test strategy. Which application do I have to test? How often? Also depending on the risk level of the data that's inside. Coding, of course. I mean, everybody knows that security is ultimately about coding and writing secure code. Yeah, and then also what's kind of a little bit missing here, but that's indirectly the same cycle would be also the supply chain. So I have third-party software components that also could be vulnerable. how to deal with those things. Shifting left means starting earlier, starting at the requirements analysis already. This is an example threat model for account security, where I have things like password guessing, account lockout. What do I do against those things? So that's a very rough example of how what this could look like. Now, we need to bridge the gap between security and agility. Now, that's the hard part. And this gets me to the question, what is DevSecOps? There's no real very precise definition of what that is, but it basically is thinking about security from the start, right? So there's no such thing as 3 different types of people. There's the developers, the security guys, and the operations guys. There will be certain people focusing on certain areas. Don't get me wrong. Again, we don't, first everybody is everything. Then we go up that hill and say, okay, we need to separate. We need separation of duties. Everybody needs their own duty. Then we're going to end up saying, okay, this doesn't work neither. We need to be somewhere in between. So there need to be people that have skills in all those areas and are able to communicate with all of those teams, but there needs to be people also specializing in certain areas, okay? But there needs to be people that can communicate between those parts. DevSecOps, and this is probably the most important part from the technical perspective, is DevSecOps is about automation and measurement. So we need to automate things. In an agile environment, I cannot do a penetration test every 2 minutes. I will have to do some sort of automation. I'll get back to this from a more technical standpoint later. It's also about sharing between teams. So if you have 5 silos of teams and everybody's doing their own thing, DevSecOps is not going to work. Automation is not going to work. You're not going to buy and install and operate your own automation security tools, every team, right? There needs to be some centralized way. There needs to be, for example, say a DAST, the dynamic application security testing tool, somewhere that everybody can use, right? DevSecOps is also about evolving from immediate pain to strategic focus. So we don't want to just always be running behind and getting maybe some reports about vulnerabilities, fixing them, and that goes over and over again, and we never get on top of that. We want this to be solved and to get on top of that in terms of focusing on what the strategy and altogether looks like to be able to operate more efficiently in terms of security. Now, if you ask people whether the security teams are involved in technology design and deployment, so in phases that are typically not just development, but everything around that, then the team members, so the technical staff like developers and operations guys, that's the lower circle, about 39% will say yes, security team is involved. Now, if you ask the leaders, so the C-suite respondents, 64% are going to say yes in the same companies. So this also illustrates that the perspective on how well security is integrated in the teams is pretty different if you ask the C-level people or if you ask the staff that actually makes the product and runs the product. Okay, perspectives are pretty different. If you want to DevSecOps to make it work, so to go on that part of the hype cycle where you can see that this is actually helpful, we'll have to start with simplification. And simplification means that we have to be able to reuse a common tech stack. Now, that doesn't mean all of the company and all the organization needs to use the same programming languages and frameworks and stuff, but it does help to have one standard and supported tech stack for the tools, because the reuse is going to be easier. If you have one static analysis tool that is specialized in Java applications, and where people work on it and maintain it, it's going to be easier to throw in just that one more Java application afterwards. Now, it doesn't mean everybody needs to do the same thing, but a certain set of common tech is advisable if you want to go towards the direction of DevSecOps. So simplification of your tech stack. There can be that one component where performance is very, very important that you implement in Go or Rust because it's quicker and it's a very small component. That's okay, but have a common tech stack. Now, if you look at organizations where this approach works, you can see that they started with an existing pocket of success. So there was that single team that already had their tools in place that worked pretty well, and other teams could see that automation works well for them and it buys them time to do cooler stuff and do other stuff. Now, every development towards DevSecOps works that way. So take a team where this works, take this existing pocket of success and try to push it out to the rest of the company. Would also mean that you make source code available to the other teams so they can see how they approach the problems, right? But again, it's not, there's two extreme sides of how teams are going to be set up. So you have this development team for one product. Does it have to be in that way that you put one security guy in there that's responsible for security for the product, or is it a dedicated security team that's responsible for the whole organization? Now, the truth is, something between is very helpful. If you have your team that does that runs and operates the automation tools, but still have one point of contact, maybe you can call it security champion, whatever you want to call it, one person in each team that understands, that speaks security, and that serves also as a point of communication for the rest of the security team organization-wide. Automation is key if you want to do that. So self-service security tools is where we want to go if we want to be successful with this. So have tools that work for the common tech stack. So for many organizations, it's, I don't know, Spring Boot plus Angular and the front end maybe, or whatever it is. Have a set of tools ready that supports those technologies. And if this is 70% of your organization, you have 70% tested. That's a lot. Okay, we don't want to be at 100% always. It's not going to work this way. Now, if you have such also a centralized team with security specialists in there, make sure to pick people that have good security skills, of course, but also social skills, because traditionally security guys like me are those who are hated by others, right? That's a little bit of extreme explanation, but you know, you're the one that comes and does a test and finds vulnerabilities and starts pointing fingers at people and says, this is wrong and there's wrong and here you could do better. This doesn't make people particularly love you at all times, okay? So it needs to be people with good social skills that can get their point across without, you know, pointing fingers and without making the security team give them a bad press, so to say, in the organization. Okay, work with both empowerment and accountability. So if you empower people and give them resources to build tools, also make sure to make them accountable for what they do. So not only give them money and time and then they do and whatever comes out, comes out. So make sure to also make them accountable for these things. Now, a culture of continuous learning is maybe or probably the most important thing of all, because security can be hard. If you want to assess the security of a system, what you need to do is to understand everything in detail around it. So your program language, your framework, your runtime, your operating system, your virtualization, your container technology. There's so many things where the security aspects inside that it's necessary for you to also continuously learn about those things. Otherwise, you're not going to understand security. So let's face it, you're not going to change the culture overnight. That's not going to happen in one day. So take your time, but be dedicated and also enforce accountability for those people who work on it. Now, I want to stress one thing that is, from my point of view, a common misconception about how developers learn security. Now, the common conception from my point of view, as I perceive it from people, is you have this developer that learns software development, is a very good developer. Now, this developer learns security, means he reads books about security, or she does a training on security, things like these. I don't think it's two parallel developments, development and security. I think one is on top of the other. So when you start writing code, and this is just, you know, everybody starts writing insecure, messy code, and you write clean code, then you start understanding that high cohesion, loose coupling is a good thing. So write a module that does one thing and does one thing well. Loose coupling, don't have too many dependencies so that you can test the code, then actually write tests, then start hacking your own code and try to circumvent your own security measures, and then write secure code. So it's a linear development. It's kind of, somebody who's good at security is usually just a good software developer. It's a linear development. And that's why education is a very, very key point in this. I also do lots of trainings about software security, web application security, and I think this is what makes people good at those things. Now, if you want to give somebody the role of a security guy, make sure that they also can do it. They have the appropriate skill level. I have this picture because this is a table that I made for myself. It's a table that's staying on a terrace. And when I did this, I really I forgot the time for a whole day, right? I was working on this thing and I was loving it so much because I was neither overwhelmed by its complexity, but neither was it too easy for me that I was bored doing it. So it was just at the right level. If you want somebody to have somebody in security, make sure that the same thing applies to them. You can actually see that table up there. They're stable, standing, working. It hasn't broken. So yeah, security is at a higher skill level of a software developer. Make sure to pick the right people. That's what I want to say. So which test should I start with? So if you think about unit tests, functional tests, I can hear you laugh virtually. Functional tests or unit tests, integration tests, people ask me, what should I start with? Now, if you write one test, write a single integration test. Something like you have a backend, you have a front end, you fire up a whole instance with test data, and then you just open the login page and you test automatically whether that login page appears without an error. Why do I say start with this and not a unit test of a detailed part of your software? I say this because with that one single integration test, you have 15% of code coverage just with one test, because it's going to touch a lot of code. If anything breaks in these 15%, you're going to notice. So start with a very, very simple integration test and you will have a good coverage. Don't start at the detail, start at the big picture. When it comes to automation and security, what should I automate first? Now, I cannot stress this enough. Known vulnerabilities in your third-party libraries. So that's very, very important. And there are free tools, for example, OWASP Dependency Check that does that really well. Don't start with Dust, EAST, SAST. These tools tend to be expensive if they are good tools, and they tend to have you have a very hard time integrating them well. If you look, for example, at Dust, I'm going to show you an example. We have this microservice where you can get a profile picture and you pass it a parameter of the thumbnail with. If your Dust tool, Dynamic Application Security Testing, it tests in a running environment. If you keep hitting that profile picture endpoint without the parameter, you're always going to be hitting the input validation because it's going to say that parameter is missing, right? And if you just point a ready-made tool at your running application, it does not know which parameters have which values that make sense, you're always going to be hitting that same input validation. You're not going to reach any depth of scanning. So be aware that dynamic application security testing Dust takes a lot of time to set up properly. I've done this with customers, and it takes a long time to actually get value from such a tool. Now, if you get results from such tools, they are just symptoms. So make sure that out of these results, you do something with them other than just fixing them in the code. So selective fixes are just painkillers. They are just symptoms. They don't really solve the problem in the code. Make sure to map this back to technology decisions, map it back to requirements, to your design, to your threat model. Talk to people about it so that they learn about this vulnerability and so on and so forth, so they can actually get some value out of it. So performance indicators could be something like a number of vulnerabilities per lines of code and so on. Make sure to also always put those numbers in context, because if you say this application has 10 vulnerabilities, the other has 100, maybe that other one is 10 times bigger in terms of lines of code. So make sure to put those things into context. Now, there will be vulnerabilities, there will be attacks, there will be stuff going wrong. The difference is only which team deals well with those things and which does not. That is what actually makes a big difference. So let me jump to the conclusions and to the key takeaways. DevSecOps is a culture thing, and culture things take time. That's not going to happen overnight. It's all about doing stuff earlier and doing stuff quicker, and take some parts out with automation. Security is hard. Consider that when assigning roles. So there needs to be a certain maturity level in terms of the software development, also understanding the whole tech stack, which is important. And the difference between a good team and a bad team is not if they have the best tool and the most expensive gear. It's how they deal with difficult situations, when vulnerabilities pop up, when attacks happen, what's going to happen afterwards, what are people pulling out of this. And these are the steps that are important if you want to go towards DevSecOps. I'm not going to read them again. So, yeah, so that's it. So if there are any questions, please